Hi and welcome to Cherry Pie Math. This video is going to go over some geometric shapes, especially the ones in 2D and how we might classify them. So to start off, I want you to think of yourself as a baby, or maybe you know a baby, and think about around like when you start playing with toys and what kind of toys you played with. You probably played with like blocks or stacking or like balls, right? They're all things that have a shape to it, something geometric, and that you were able to figure out like, oh, these shapes go with this shape, or you were able to stack them or stuff like that. And it's really cool to see that the human brain understands mathematics first through geometry. We first look at shapes, and that's how we make sense of the world, because we're able to categorize things into different shapes, and then based on those shapes, then we're like, oh, a triangle has 3 sides, and we start to build that understanding and connect it with counting, and then more mathematics is born from that. And that is actually the way that history has worked as well. This guy, his name is Euclid. He's Greek. He compiled a book called The Elements, and The Elements is basically a bunch of proofs, or kind of like mathematical essays, I guess, or logical reasoning pathways, I don't know, but he basically showed how to do things in geometry, and this was like the math textbook for years. Like, I'm talking all the way into like the 1700s. Like, people use The Elements instead of algebra. Our modern understanding of algebra is actually more from Arabia. It's actually named after a guy named Al-Jabr, which I probably butchered the way that I say that name, but they were the ones that kind of started using letters for X and Y and like unknown variables and solving for those values, but that understanding came from geometry. And so to start out kind of thinking about geometry, just grab a paper and cut out some triangles, make like 4 or 5, and think about, what do all those triangles have in common? What makes the triangles different? And then what are some conditions of the triangle? So I'll give you a second, and then you can just pause the video and go make some triangles. And then unpause the video when you're ready. Okay, so probably you notice that all of your triangles have 3 sides, right? If it doesn't have 3 sides, then it's not really a triangle. The different triangles, you have different side lengths, you can have different angles, sizes, like the measure of the angles. But I guess to be a triangle, it has to have 3 sides and 3 vertices, and it has to be closed. You can't just have like this has 3 sides, but it's not a triangle, right? Or 3 lines. So it has to have 3 vertices. And actually, I think the definition of a triangle is you have 3 points, and then it's just the space enclosed by making line segments out of those points. So to start off, let's talk about what a geometric shape is. And a geometric shape is a figure that's 2D or 3D that is enclosed and is made of line segments and angles. And it can be 2D or 3D, like I said. And so, like, these are very basic geometric shapes that you probably have seen since you were a baby. We have 3D shapes as well, and we'll kind of go over how to name those in just a second here. But that's really all it is when you're talking about a shape is. And honestly, because we don't have time in mathematics to talk about like dodecahedrons, we usually just focus on these folks here. And sometimes we go up to like a hexagon, but really that's it, because other than that, it's like we get into like, I don't know, 23 sides, and I think honestly at that point you would just call it a 23-agon. So here are the basics. We have a circle, and we're just going to freehand these. Woo! We have a triangle. And this is cool because I can just like hold it so it looks prettier than if I just drew it otherwise. We have a square, we have a rectangle, we have a rhombus, and a rhombus is a shape with 4 sides that are the same length. So pretend that those are the same length. And Sometimes we'll use these marks, and if your line has one mark, it means that every other line with one mark is also the same length. And then we have a parallelogram, which that should be like this. And another symbol you might see, so this means congruent. It means that they're the same size and length. We might also see this symbol. It kind of looks like an arrowhead, and what that means is that they're parallel to each other. So if you continued the lines, they would never touch. Because they run parallel to each other. So like those ones would be parallel, and then these two sides would be parallel to each other. So those are some symbols that you might see. So a circle has no sides. I can spell. And the outer ring is all the same distance from the center. So if I have the center here, this length here, R, is the same as this length here. We call that the radius. It's the length from the center to the outside. In a triangle, we kind of talked about that already. We have 3 sides, 3 vertices. It's enclosed. I guess I don't have to write enclosed because all of these are enclosed. And another thing about triangles is that interior angles add to 180 degrees. There is like a mathematical proof of this, a way to show that it will always be 180 degrees no matter what triangle you make. But we're not going to go over that right now because that's not part of this lesson. If you're really curious about it, just go Google it, I guess. A square has 4 sides of the same length, so we'll call that congruent. It has 4 right angles. Remember, right angles means 90 degrees. And yeah, that's about it. A rectangle is like a square in that it has 4 right angles, but and then it has 4 sides, but it doesn't have 4 congruent sides. Whereas a rhombus is similar to a square in that it has 4 sides congruent, but it does not have the condition that there's 4 right angles. So a square is actually like the love child of a rectangle and a rhombus because it is both a rectangle and a rhombus. And a parallelogram has 4 sides, and opposite sides are parallel. And you will see this again in the future when you do more geometry, whether it's in junior high or middle school or in high school. You will see more of this because these definitions help build the understanding of other proofs, because proofs are such a major part of mathematics. There's one more fancy word I want to use. These 4, and these aren't like all inclusive, but these are classified under quadrilaterals. Quad means 4, and then laterals means sides, so it means that they're 4-sided figures. So what makes a square different than a rectangle, just in general? What do you think? Hopefully you would think that it means that all the sides are congruent, are equal. They are the same length. So a square is an example of what we call a regular polygon. Oh my gosh, I can't write on this today. And I'm going to pause here for a second. So the word regular, I don't really know why they decided to call it regular polygons. They just thought that was a cool word, I guess, to use. But polygons means multiple sides. So it means that all of the sides and angles are the same. So you might see that in like an equilateral triangle, for example, the sides are the same, and you might see that all the angles are the same. But we can see this in all different kinds, all number of sides, I guess. So let's draw some examples of regular polygons. If we have 3 sides, it's obviously going to be a triangle, and this would be called an equilateral triangle. triangle. And then for 4 sides, we have a square. And that's kind of where the special names and the other ones are all built in the same way. So 5 sides, it would be called a pentagon because pent means 5. So it would look like this. This is an ugly pentagon, so you'll have to pretend like it's a beautiful polygon, where beautiful regular pentagon where all of them are the same. So this is a regular pentagon. And then we have a regular hexagon, which again, it's going to be so ugly. But you'll get the gist of it. There we go. That's not the worst it could have been. So all of these angle sizes that I wrote mean that each of these angles are going to be the same amount. It's the same amount of degrees. So like this is 108 degrees right here, or this is 120 degrees if it was a perfect regular hexagon, which let's pretend it was, and let's pretend that I can draw on my iPad. Triangles actually have even more specific things. So I'm going to draw this equilateral triangle here, which we just covered. It means all sides are, and angles, I guess, and angles are congruent. We also have right triangles, and those are the ones that look like they have a corner because they have a 90 degrees. One angle is 90 degrees, so it's a right triangle. Isosceles, that's how you would say it, is isosceles, kind of fun to say, means that 2 of the sides are equal to each other. So these 2 sides are congruent, but the third side is a different length. So we have 2 sides the same. Actually, instead of same, we're going to say congruent. And then scalene is the last kind of triangle. It means that none of them are similar. And these ones are kind of hard to draw because honestly, I always end up making like one of the other ones. So we'll just use 3 different markers. And remember, those mean different lengths. So this means each side is a different length. Each side is a different length. And it also means that it's not really a right triangle because we wouldn't have a right angle. So other properties of triangles, like I said before, they all have to have an interior angle sum of 180 degrees. What does that mean, you ask? It means that if I took each angle here, so if I added this angle plus this angle plus this angle in any triangle ever, it would equal to 180 degrees. One other cool thing is that 2 sides added are always greater than the third side. So it doesn't matter what the triangle is, if 2 sides are smaller, if you add 2 sides and you get a smaller length than the third side, then it's not a good triangle. And you'll see this, I would give this to my 10th grade students, where I'd say like, oh, see if, I don't know, 6, 7, and 15 would be a triangle, and 6 plus 7 is 13, which is less than 15, and so it wouldn't be a triangle, for example. To do this last bit, the drawing part, where you need to know how to use a protractor. So we've freehanded a lot of these pictures, but sometimes you're going to want to draw like a specific thing, or you're going to want to make like a right triangle with exactly 90 degrees. So this is a protractor. I got it from this Google search. The way it works is, as you see, you have a 0 on both sides, but they're on different things. So this one starts at 0 and heads upwards, where the other one starts at 0 and goes upwards the other way. And it's really cool because what you do is you put the center at what we call the vertex. So where the 2 rays meet, you make sure one of the rays has to line up with one of the lines, and then you see where the other one ends up. So this one, for example, we started on this side at 0, so we would follow here. This ends up being like 128, and that would be 128 degrees, for example. So I'm actually going to go ahead and try to use that to make an equilateral triangle. So I just drew it because I was on a computer. But we know that an equilateral triangle has to have 3 sides that are the same length. So let's call this, I don't know, like 5 centimeters. And we do want to make sure that it's 60 degrees. So if I head back to my protractor here, I can also use it to draw. So I start at my vertex and I make one line here. So there's that. And then I have 60 degrees right here. So I'm going to go through there. There we go. I'm going to copy this sucker. There we go. And I copy it. And I paste it. And look at that. It's 60 degrees. It's so cool. So anytime you make an equilateral triangle, you want to make sure that all those sides are 60 degrees. The way I would draw it if I was to do it from scratch is I would just start with a line, just any line, and then I would measure 60 degrees. And then I would say, okay, we'll make it, I don't know, this long. And then I would go here and I would make another 60 degrees, and that would make my equilateral triangle. And a pentagon, similar to that, you would kind of start with one side. It can be any side really. And then you want to make sure each side is 108 degrees. So you would use your protractor and make sure you make another line that's 180 degrees. And then you would pick a part and then that you would want to stop the line and make another 108 degrees. And then you make sure that that same segment stays the same length throughout the entire pentagon. So here's a chart of regular polygons. As you can probably see in each of them, they start with the number of sides. And then, but the only two that really have different names is equilateral triangle and square. Everything else after that is the name of the number of sides and then gon. So like octagon, oct means 8, gon means shape, etc. And the other cool thing is that the angle sum changes. So if you look, each time we go through, they add 180 degrees. And that's a cool way to figure out how much each angle is going to be. So for example, like if I was to go from 9 to 10, I would add 180 degrees to the total, but then I would divide it by 10 to get 144. So if I was to do one for a tridecagon for 13 sides, there's a couple ways you could do it. I'm just going to add 180 a couple times because I know that this is 10 sides. So if I add 180, that would be, let's see, 0, 2, 6, 1. That would be 11 sides. Then I had 180 again, and that would be 1800. That would be 12 sides. And then, I guess this is more of an arrow. And then I would have 1980 for 13 sides. And then I would divide it by 13 to find the amount of the measure of each angle in a tridecagon. If you want to use technology, which is also in the Utah core, you can go to what's called GeoGebra. There's a couple of websites. This is the one I used when I was in 7th grade, so I just kind of used it my whole life. But if you go to GeoGebra and you press geometry, you can kind of play around with how to make a triangle or how to make a square or whatever. So like I said before, when you're making a triangle, it's really just 3 points and then you connect them. So what you would do is press point and you would make 3 points. And then polygon, and you can just kind of highlight them and then it'll shade in the part for you, which is so cool. So some things to remember. Regular polygons all have the same side lengths and same interior angle measures, and that's and most of the time we will use regular polygons except for triangles and quadrilaterals. Triangles have lots of different classifications. Make sure you learn all 4 of them. Protractors can be used to measure and create angles in degrees, and this is a really tactile way of drawing triangles. You're not going to use them as much in high school, but you are going to use them in like junior high. And geometry is the earliest form of mathematics. A lot of mathematics, as we know, is built off of geometry. Okay, I hope that introduces shapes. That was kind of a long one, but I hope that helps.